I wanted to get that started. Okay. And then you answer your question. Okay. How well do you think any anatomy class, face to face or online like you are, okay, is going to do on that test out of 100% possible? Now, there's no extra credit on the lab practical. That's the first time I've done that because I'm giving you the extra credit for being here right now. Okay. You have just as much extra credit, and it'll be not hard to accumulate. What do you think the score will be for the class average? Now you
75,
said, go ahead.
80%.
75.
Okay. Allison,
Yes.
what was that you?
Oh, I said 75.
Okay. There's a little bit of a delay both ways here. Okay, so, and I just look for the highlights so I can see who's talking. Okay, I
Maybe
heard
80%.
80%, Julie. Okay.
Yeah.
Are you being optimistic? What's an 80% in any class? What would an 80% be? An A, a B,
B.
A B?
the damn lowest B? You're on the verge of a C already. Talk about 80%, 79%. Okay. Unacceptable. Totally unacceptable. Okay. We don't get scores like that. Oh, we get a few people that will get scores like that, but I was saying class average. Okay. I expect the class average to be very close to 98 to 100%. That's how it usually is. In the summer, in the past, I would give 105 points, counting 5 points extra credit. You'll already have that extra credit in the bank for your attendance here, okay? Which I hope is very helpful. So I don't expect you to get over 100%. It won't be possible. But 96, 7, 8, 9, 100. Okay, for class average. I'll be very disappointed if it's less than that, and so will you. Okay, so we aim for that. I want you to know it's attainable. We always get it. And where do we get it highest? In the face-to-face normal classes or in the maybe online summer classes?
The online summer classes.
Yeah, you figured me out. Okay. Actually, I haven't taught online summer. I've taught online fall, online spring, and the online courses always do better. Always do better. In studying, I know I made some recommendations of ways or options that you could study. One, alone. Two, with a partner. Three, with a group, and so on. Okay. And I was asked yesterday towards the end, after most of you had gone, am I recommending that you study in a group? I don't know what's best for you personally and what you like and how gregarious of a person you are. Okay. But I'm a loner, and I would never recommend studying in a group. No, take it for what it's worth. You study in a group if you want to, but I feel with groups you run the risk of the slowest person holding everybody else down, or the sharpest person, or maybe a person who's taken the class before, going on so fast that the others get intimidated. It doesn't feel good. Okay, and uh, I really think personal study is the best, but that's me, and you have to decide for you. But I am not recommending groups be formed because somebody thought in fact, had said that. I am not saying that. Okay, so I'm hoping for a good A average for this first test. This is going to be the easiest test you'll take in this class. And you want to have the highest score possible because you'll probably be feeding off of the points for practicum 1 to fill in some points that you didn't get on the other practicums. Okay, what else? Patricia, you're not muted.
Yep.
Okay. Okay, well, if you want, we can go ahead and get started, but if we have questions, this is a good place to ask them because everybody gets to hear the answer.
Can you go over the anatomical position and directional terms again?
I'm going to do it if in doing it, I'll do it very fast. Okay, because one thing is, yes, I already did it, but maybe too fast for you. And two, the recording for yesterday is up and you can always review that way. But I'll do it today because
Thank you.
it does not take very long.
Okay.
Okay. Now, if you ask me to go over the nervous system or something like that, no, I'd have to refer you to either the recording or refer you also to emailing me and we set up a time where you and I can talk.
Okay.
Okay, anything else before we head that way? Okay, now I'm going to do the shared screen thing, see if I can get it. Are you seeing the cursor?
Yes.
You are?
Yes.
Oh, then that actually works, huh? Great. That part of it works, but this is not what I want to look at. So still go through. Okay, here are our modules, and you see the cursor. Otherwise, you tell me you don't see
Yes.
anything.
See it.
Okay. Remember also, if I ever kick out the sound, it's possible here. I've got it taped so it won't. But if I ever kick out the sound, you're going to all show me a yellow hand or a yellow card or whatever they call it, you know, the icons, the emoticons. And I see a bunch of those and I'll know what happened. Okay. We had sound out one time and people didn't know how to tell me. They started waving at me in the screen. That didn't work. Finally, somebody had a writing program. They could write over what I was doing, and it says, "We can't hear you." But that's slow. Okay. Before here's the meet and greet. Here's assignment number 1. Okay, there'll be an assignment number 2 tomorrow. Okay, so you got to keep up. It really doesn't take long. I have inserted my website. The website is used not by Canvas, and Canvas would have a fit if they knew I was using this, but I want to get the information across to you. This is a website I set up for face-to-face classes, and I have been using for many years. You can refer to it if you want. So let's go and take a quick look at Charlie's website. Click on it. Now, you'll notice here, nothing happened. It came up blank. That happens on some external URLs. And when that happens, just click the title. And here's the Human Anatomy website for your summer 2021 class with the ticket numbers and such. Includes a phone number which is useless to you. Just email me and you'll get a very fast response. Okay. The lab, there's some lecture material over here that'll be duplicated throughout the course, but under lab material, okay, I'm directing you just to see your syllabus that I've given you already for the dates. But for Unit 1, that's what we're in right now. That's the skeletal system. There are some what we call web links, links to other places on the internet. So you click that, web links for Unit 1. Open it down here. Open. This used to have about 50 links, most of which were useless. So I have pared it down to about 3, enable editing. Okay. And these include bones of the body, a practical exam on the skull, and more quizzing. You don't have to use these, but they're extra study material. To open this, I have to hold down, and it tells me, control, and then click. So control converts it to a finger, click, click again. There it is. Pick a bone. Okay, any one that you want to see, any part that you want to see. Well, we're on the skull right now. Let's look at the anterior of the skull, and we're being welcomed to the bone box. Okay. Anterior of the skull. It's showing you several things, most of which we have looked at. In fact, all of them we will have looked at by today. The lateral side. By pressing on a number, like number 7 here, the answer as to what it is comes up here in this dark blue area. Coronoid process of the mandible. We haven't done that yet. We're going to do it today. We have done the parietal bone, which is back here, the temporal bone, which is here. Let's look at the parietal, be sure it works. Click on it, and that's the parietal bone. So this is sort of a self-quiz that you can do, and you get an instant yes or no, that's it. Back out. And it won't back out any farther. So I'm going to knock this off and go back. Open it again. I'm just going to show you the second one. Enable the editing. Open the second one. And this is a quiz. Okay. Question and answer. You got to realize one thing. This is an old web page. The person who built this web page didn't do a bad job for the time, just didn't know how to build a web page. But it's good for what we need. The skull. Let's do the ventral view. That's from the underside. And hit the Q. There it is. Lots of numbers. The answers to what letters A through I are go here. Well, you can write them on a piece of paper if you want to, or just do it mentally. And then you can get the answers filled in by hitting the A. There you go. So you don't need your own bone box. It's nice. I've got, as I said, a bone box sitting over here, but I won't get that out until we've gone through it with the images, and then I'll do the bone box. Okay, I'm finished with this, so click it off. Here's the website again. There's lots and lots of information on the website. That you'll have access to, that you won't have access to on Canvas. But I'll direct you to it when it's time. Okay. I get the tabs up at the top, and I don't need that tab anymore. Now I'm back into the module, and it's blank again. That's okay. I know what to do. But I'm going to back out with the arrow. Okay. And here we are. Okay, so there's a website there that should be able to help you. I've reduced it to 3 links that I think are good. Okay, out of the 30 that were provided, those 3 can really help you out. Okay, this is going to be quick now because it's recorded and we did it once. Okay, doing something once isn't enough anyway. You've got to go over this material again and again until you feel that you know it. Don't stop when you almost know it, because you'll only almost know it for the exam. And that won't get us a 98%. Okay. I really am expecting high 90 percentage. Okay. So this is anatomical position facing forward, palms facing forward also. Laterally, the thumbs stick out. Superior means that one part is higher up, closer to the cranium, closer to the top of the head than something else is. So for instance, the chin is superior to the abdomen. The chin is superior to the thorax or chest. The opposite is the inferior. The chest is inferior to the chin. The chin is inferior to the mouth. The mouth is inferior to the nose. These are not words of quality. That doesn't mean that something is a superior grade or an inferior grade. It's location. The next things were lateral and medial. Lateral is away from the midline. Medial is towards the midline, which is right here. The most lateral part of the hand is the digit 1, which is the thumb. The most medial part of the hand is digit 5, which is the little finger. The closer you get to the midline, the more medial you are. Then we have proximal and distal. These terms are not exclusively used by the appendages, but mostly by the appendages. So if we look at an arm, the proximal end of the arm is where it attaches. This is the proximal end, this is the shoulder, okay? Going away from that, we're going distally to the elbow, and even further distally to the palm of the hand, and most distally to the fingertips. Any direction away from the fingertips is going more proximal. The elbow is proximal to the hand. The elbow is proximal to the fingertips. The elbow is proximal because it's closer to the proximity of the start of the appendage. Anterior is completely the side that we're seeing right now. And we've all had experience enough that we know there's a backside to this person, and that's the posterior. That seems so obvious. Anterior, we know what the posterior looks like. Okay, but when we get to histology, you've never seen the anterior versus posterior most of the tissues, and we'll have to talk about it then. But here, It should be pretty straightforward. Okay, now I went through that really fast compared to yesterday, but I would call it a bonus.
I appreciate it. Thank you.
You're welcome. Back to the modules. And here's all we have to do today. All, we're going to have a lot of terms. We're going to have a lot of terms on 6.8. We're done here. Here's the recording from last night. If the recording, I don't know what will happen when I start it here. When you start the recording, if nothing happens, nothing did happen. Well, then you open the recording in a new window right here. And there it goes. It's there. Okay. Well, YouTube, this is where I post it on YouTube. They're all there. YouTube tends to want to recommend crap that I don't want to see. And it's along the side here. No, I don't care about the Addams family. Oh, God. Okay, so you can just ignore that, or you get bored, click on something. Okay, this was from yesterday's lecture when we talked about the planes. Okay, and you would start this, of course. Now you have to listen to me. You can turn the sound off if you want temporarily. Move ahead to the section that you need. Okay. And I'm going to turn the sound back on just in case they turned it off completely. Okay, I don't need it. Taking it off at the top. Would you think anybody would look at the recordings again?
Yes.
As you get closer and closer to the exam date, then they get looked at. Especially as you get closer to the final exam. Boy, then they get trashed or thrashed. Okay, we're going to do the joints today in lecture, and then we're going to move to lab and do the other part of the skull. Okay, those are the only two things we're doing, and other than answering further questions that you might have. Here are the joints. Joints are also known as articulations. As you move your hand, scratch your head, adjust your volume, use your keyboard, use your mouse, whatever you're doing, and you can see something happening. You're using an articulation. You're using actually a specific type of articulation that we'll be talking about. Okay. Not all joints move, however. The joints in the skull that make the skull case or cranial case are not supposed to move, at least not very much. Okay. They're there to protect the skull itself and contain the brain. The articulations are usually classified or discussed either in terms of their function or their structure. I got that right off of the first line here. Okay. It's hard for me to seem original sometimes because I wrote this and this is the way I think. So, I mean, even if I don't look at it, I'm going to say the same thing sometimes. So please don't always think I'm reading. Okay, most books do look at articulations from either of one or two aspects. One, their function, and two, their structure. Okay, and they often look at function and structure separately, which is foolish. You need to look at structure and function at the same time. You don't have one without the other. Okay, so it's important to understand both of them and being able to visualize it in your mind. We're going to look, however, at the functional types first. Then we'll look at the structural types of joints. And then we'll make sort of a roadmap as they come together. And what one function and one structure paired together give us. Okay, don't worry about any of that yet. We'll go to functional types. Function, what it can do. The first type of functional joint is the synarthrotic joint. Syn means together, arth means bone, synarthrotic, bones that are together, not only just together, but not movable. Synarthrotic joints refer to joints that aren't movable. They're held tightly by bony tissue, that's osseous tissue, and it interdigitates between two bones. If you clasp your hands together, I know I did in third grade. I sat in the front row with my hands crossed and interlaced, trying to impress the teacher. There's a reason for that you'll hear later. But when you do that, pull apart, they pretty well are stuck together because your fingers are interlaced. At the top of the skull, the sagittal suture, the zigzagging here between the two parietal bones, has a lot more surface area than it would if it were a straight line. Bony fibers extend from one bone to the other and join somewhere halfway across. This makes for a very rigid structure. Okay. Touch the top of your head, you don't expect it to cave in. Okay. So this is a synarthrotic joint. This is a synarthrotic joint. This is the coronal suture. This is a hole drilled in the skull to insert a metal rod so that we could put the skeleton together and have it stand up. So don't worry about that guy. Okay, these are synarthrotic joints. They also happen to be sutures, but we'll come back to that term once we talk about the structure along with the function. The function here is not to move. That is a function or lack of function, however you want to look at it. We okay with that?
Yes.
Yeah.
Okay. Move on. We have an amphiarthrotic function. These are joints that are slightly movable. Now, they don't have a good picture of this because we'd have to have motion. But if you grab your forearm, not your upper arm, that's your true arm. If you grab your forearm, there are two bones in there, the radius and the ulna. They are attached to each other at the distal end and up at the elbow at the proximal end. And as you now twist your arms, your forearms, laterally, medially, just sort of turn them. There's a slight separation, a slight movement of the radius and the ulna, but not a great movement. It's very slight. That's called an amphiarthrotic joint. In your lower leg, now your leg is not your lower leg. Your leg is your thigh area, the upper portion. Go down below the knee and you're in your lower leg, as we call it. Between the knee and the ankle, there are two bones, the tibia and the fibula. They are attached to each other at their proximal and distal ends, but not firmly. They can twist just a little bit. especially in sports, we know that they are not quite so rigid. When we talk about clipping or breaking of a fibula, okay, they're not the most rigid things, but when we think of them in normal use, they're we don't even think of them as movable, but they are slightly movable. The term for slightly movable is amphiarthrotic. The third one is diarthrotic. That means fully movable. Now, there's no such thing as a fully movable joint, but in anatomy, sometimes we take liberties. If we had fully movable joints, we could twist our head all the way around, like in The Exorcist, and spin it. But we can't do that. Okay. If we have a fully movable joint, we could extend the forearm at the elbow, but it wouldn't come to a stop. And it does come to a stop. Okay. But when you look around at anybody uh, on the screen, I've got you turned off on the screen, you see motion, you see movement, except for those who have pictures. Okay. Uh, you can just look at yourself. Any motion that you can see emanating from you is from a diarthrotic, fully movable joint. Clench your fist, your fingers are all moving. That is diarthrotic, fully movable. They have a special structure that we'll get to in just a second. Well, what are the structures? One type of structure is a fibrous joint. A fibrous joint has interconnections by connective tissue fibers, such as bone. I mentioned that a while back, right here. These are interconnected, and this is a fibrous joint as well. It was a synarthrotic, immovable joint, but it's also a fibrous joint. Okay. Imagine you're wearing a pair of shoes that has laces, and you tie those damn things up so tightly that you can't wait to get them off, for one thing. They have no give in them whatsoever. Oh, that's the situation you have here. A fibrous connection from one side, in this case of the shoe, to the other side. Loosen that connection somewhat, and we'll have a different type of joint to talk about in a moment. The cartilaginous joints. These joints have a type of cartilage called hyaline cartilage between their bones, and it often cushions the articulation, the joint, and prevents damage. We have cartilage at the ends of our femur. We have cartilage on top of our tibias. Okay, I'm picking those because I think you probably know those. Okay, and they begin to stop damage. We also have an area called an epiphyseal plate, and this epiphyseal plate is going to be made out of cartilage. And let me pick a good one. Here's the top of a bone. It looks to me like it might be the top of the tibia. You have bone here. You have a little bit of cartilage on the outside, the articular cartilage. And here's the lower portion of the bone. But between the lower and upper portion, of an immature tibia, you have this cartilage. This is a cartilaginous joint. This cartilaginous joint will disappear as you get older. A few cartilaginous joints stay for your entire life. Over here, here's the end of the tibia. Here's the fibula. Here's the foot. Okay. There is some cartilage in between here. Articular cartilage. It doesn't show on an x-ray. But these bones, the tibia and fibula, look to be broken. They are not. This is an x-ray of a younger person, and there is cartilage in here. This is going to be called, and I'll give you the term in a moment, epiphyseal plate. As you get older, this cartilage gets reabsorbed, and the two parts of the bone that look broken here mend, and that will be the end of their ossification, as it's called. Ossification we'll be talking about tomorrow, but it's the bone formation. This will disappear also. It disappears at specific times, specific ages, and it doesn't seem to matter the ethnic background of the person, where they came from, or anything like that. That's about the same age for all of us. Synovial joints are freely movable joints. Didn't I say that before? Diarthrotic joints are fully movable, freely movable. A synovial joint, however, has a sac between the two bones that make up the joint. That sac contains a fluid that fortunately for us is called synovial fluid. Its composition, water, protein, minerals, varies from person to person and from season to season, and from your diet to your changed diet. So there's no specific synovial joint. Some people think of it as a small whoopee cushion, fluid-filled sac. It fits between, for instance, the distal end of the femur and the proximal or upper end of the tibia. You jump up and down, you run, you jog, you put a lot of stress on your knee, but you have this fluid-filled sac, fluid filled with synovial fluid, and it cushions the blow. Can you destroy this sac, the synovial sac? Yes. Okay. Can it get diseased? Of course. Osteopaths, that's how they make their living, correcting this type of situation. Okay. Do you have any bones or joints? That would be the better term. That pop? Can you crack your knuckles? Can you crack some of your knuckles? Does your neck crackle?
Yes.
Yeah.
Mine does. Okay. Sometimes when you get up, your knee pops. Okay. That's the pressure put onto the synovial sac, and fluid is trapped for a moment, and then you put so much pressure, it pops forward into another portion of the sac. and it does so with quite a bit of sound sometimes. Okay, now I do have a picture in a moment going over these things for you, but I want to come here to the types of bones that is, we have joints that are based on structure and function, both. The synarthrotic joint, remember, is not movable. The amphiarthrotic joint is slightly movable. The diarthrotic joint is fully movable. You can copy this page for yourself if you want a particular page just by hitting up here at the download. Okay, it just really opens it up, then you print it if you want it, and you can write in whatever you care. The structural types of joints, as opposed to functional, are fibrous, cartilaginous, and when I said cartilaginous, I usually refer to cartilage in a chicken, for instance. If you've eaten chicken breast, you come across the cartilage. You also come across cartilage in most, not all, fish, okay, and synovial. A synovial joint has a synovial sac filled with synovial fluid. Okay, so if you can crack your fingers between the parts of your fingers is a small sac. If you can crack your knee, there's a large sac. And if you can crack your elbow, I used to be able to do those things. Getting old, I guess. If you can crack your elbow, you've got a synovial sac. Now, let's just go back to this first two. A fibrous joint that is not movable. That's this one. It's fibrous and it's not movable. What do we call these guys? This was the sagittal what?
Suture.
Suture. So these are sutures, fibrous joints that are immovable. You can define a suture with this chart. A suture is a fibrous synarthrotic joint. You could also say a suture is a fibrous immovable joint. There's one other type of joint that is fibrous and supposedly immovable, the gomphoses. That's where your tooth fits into your jaw. I don't know how many of you have ever had a tooth out. As a kid, you did, but you didn't think much of it. As an adult at the dentist, you may hear some crackling or whatever. That's breaking the fibers that hold it in. A gomphosis is a fibrous, immovable joint that joins a tooth to the jaw, whether it's the upper or lower. That's really not too hard, I hope. Now, remember I said fibrous is, think of it as a tightly laced shoe. Loosen the lace a bit. Loosen the lace, and we have a slightly movable joint. Okay. It's still fibrous. It's slightly movable. And my examples were between the distal and proximal ends of the radius and the ulna, and also the tibia and the fibula. Don't have a lot of these, but when we do have any, they're called syndesmosis. Syndesmosis, which I don't have here, would be spelled S-I-S. That's singular. I've used the plural throughout here with the E. Don't worry, you're not going to get dinged on that because this is going to be a multiple choice test and only the correct answer will be there. Okay, so those are your best examples. Fibrous joints are never fully movable. So there aren't any. We just leave that one blank. Cartilaginous joints that do not move, that are synarthrotic, that's the epiphyseal plate. That's the part I said will eventually coalesce and disappear. These are called synchondroses. Syn, together again. And con, C-H-O-N, is our abbreviation in Latin for cartilage. This is not chemistry class. This is not carbon, hydrogen, oxygen, nitrogen. Okay. Synchondroses. The epiphyseal plate. I don't know if I have the word here. In tomorrow's lecture, it'll be all over the place. So don't worry about it. And then we have cartilaginous joints that are slightly movable. They're amphiarthrotic. Cartilaginous, slightly amphiarthrotic joints are called symphyses. You've all heard the word symphysis. Pubic symphysis, for instance, the joining in the anterior of the two parts of the pelvic region. In childbirth, that sometimes stretches, sometimes separates, sometimes is separated intentionally in order to give birth to the child. Also, when you bend over, okay, I used to, as a kid, bend over for a penny. That changed. And then I would only bend over if it's a quarter. And now I can't bend over for anything sometimes. It depends on the day. Today I feel great. I'd bend over for a buck to pick it up. But as you bend over, you arch your back, and each vertebra comes a little bit farther apart from the one before and after it. That allows for the entire arch so that you can bend over. But each vertebra does not bend very much from the one before or after it, just a little. And the sum total allows you to bend. Between the vertebra, the joints are symphyses. Symphyses. There are no cartilaginous joints that are fully movable. There's nothing to put here. Synovial joints are fully movable, so they cannot be immovable. Nothing there. Synovial joints are fully movable, so they can't be partially movable only. So there's nothing there. The synovial joint is fully movable or diarthrotic. That's the one that you can see where your fingers are moving, your arms moving. My mouth is moving and talking. Okay. These are called by the same name. They're called synovial joints. So there's only 5 types of joints. 6 if you count the gomphoses. 5 categories of joints. Here's the synovial, and we'll look at that one next. Okay, 2 bones. I don't care what 2 bones you imagine them to be. I usually imagine that the upper one is the femur, the lower one is the tibia, but there's no fibula attached here. It doesn't matter. Between the 2 bones in a synovial joint, you have the synovial pouch. Okay. Here they're calling this the synovial membrane, which defines the limit of the pouch itself. There is articular cartilage here and here. Cartilage has nothing to do with the synovial joint. This is the syndesmosis. Now, I know you don't remember it yet. Cartilaginous joint that's not movable, being applied like a layer of paint, really, is a synchondrosis. This is a synchondrosis here. And so was the epiphyseal plate. But this whole joint involves everything that you see here, and this is a synovial joint because it has a synovial cavity. Synovial cavity or joint cavity containing synovial fluid. Can't be hard to remember that one here. If you were to damage your knee badly, if you were to break from a long fall, for instance, the synovial pouch or the synovial cavity, how many milliliters or cc's, which are about the same thing, of fluid do you think could escape? How many cc's are there?
250?
250 is a good answer. More or less, anybody? The answer is 4 cc's. A cc is 20 drops. And with 4 cc's, you only have 80 drops of fluid in your knee at any one time. You don't have a lot, but fluid can't be compressed. And that being the case, can withstand a lot of force. Now, in this bone here, we did have some cartilage out here. Okay. This was a synchondrosis. Now we have bone again. And this area in sort of light color, that's the epiphyseal plate, but it does not have a label on this drawing. You will get a label. Okay. And this is also a synchondrosis, the epiphyseal plate. Means that the two portions of either bone, let's say the upper one, have not yet joined together, but are still growing.
I have a quick question.
Yes.
The epiphyseal plate is only in the premature bone?
Let me think. So I get that. Okay. When you find an epiphyseal plate, you expect to find it in a young person. Most of the ones in you and me are, well, at least at my age, they're all sealed. At your age, I'm guessing, average age of the class, you still have some that have not finished ossifying. Okay, there are a couple, to answer your question, that never fully ossify. You always have the epiphyseal plate. Just a few, though. Some terms: a suture, a fibrous, immovable joint. A gomphosis, the joint between a tooth and the mandible or maxilla. Syndesmosis, fibrous, slightly movable joints. Remember, between the radius and the ulna, the tibia and the fibula. Synchondroses are cartilaginous immovable joints, and the most outstanding example for us will be the epiphyseal plate. A symphysis is a cartilaginous but slightly movable joint. These occur between the vertebrae and between the pubic, not public, I'm sorry, I just noticed that, between the pubic bones, making the pubic symphysis. Synovial joints, these are the freely movable ones. They have a fluid-filled pouch to cushion two or more bones. And then one word that I haven't mentioned, bursa. You've all heard of bursitis. It's an inflammation of these small bursae, which are sacs. These little sacs often accompany a synovial joint. The sac would be out here, another one here, 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 and they can cause people trouble. They really don't cause people much good. We can have something that does not have a beneficial function so long as it doesn't have a deadly function or a very deleterious function that harms our ability to reproduce. So it's not going to be true in this class that everything has to have a function. Okay? It just can't have a life-threatening function, or it wouldn't be in our gene pool anymore. Okay, so bursa are associated with synovial joints. There might be 4 or 5 on either side, and they may never give you any trouble at all. But if they become infected or inflamed, it can be quite painful. I understand. I have not had that affliction. That's the end of that part. So back out.
I have a quick question.
Yeah.
Are there sutures in other parts of the body besides the skull?
When we talk about sutures, we invariably are talking about the skull.
Okay.
Just the skull. Okay, so there are 4 main sutures of the skull: the mid-sacral, coronal, the squamous, and the lambdoidal. There are minor sutures of the skull as well, but all of these sutures, you're right, are relegated to the skull. Okay, we're going to do the second part of the bones in 10 minutes. I'm going to give you till 2:20. That's 11 minutes from now if you would like it. To get some water, go to the bathroom, do whatever you have to do. Yesterday, some people left completely and came back knowing that I had scheduled till 3 o'clock. We finished before uh, 3 o'clock, 4 o'clock. We finished before that by about half an hour. So they came back to an empty room. Okay. So I'll see you in 10 or 11 minutes.
Thank you, Professor.
I gave you your screen back in case you guys want to talk to each other. I'm gonna get back out of here. Okay, we're back. Can anyone hear me?
Yes.
Okay, that's what I need. Okay, and I can certainly hear you. Anybody think of a question? Let me see if you did or not. Is somebody supposed to mention something to me? It won't be to record because we're still recording.
I think she was asking if anyone wanted to mention that we were coming up on break time, but gave us our break noise.
I got you. I see it. Uh, break time to me is when it's going to be convenient for everybody. I mean, I try not to go too far. So I went till 2:09 uh, uh, to get the material done. Otherwise, I think you lose a train of thought. So uh, I really just lecture. Then I take a look at the time, and if it's anywhere close to 2 o'clock, that's when I do it.
Are you recording right now?
Yeah.
Oh, perfect.
Yeah, I've been recording all along. Okay, so uh, if you want me to hold straight to the times, then we're supposed to be going to what, 5 o'clock? Yeah, you don't want to do that, do you? You don't need to.
No. No.
It's not just that you don't want to because you love the course. You don't need to. You're going to have enough material, okay, that for those of you who want to continue on till 5 o'clock could easily do it on your own. I did my part in putting it together. That's called asynchronous. And uh, so you can also come back and do it later. You almost do have to put in the time though, because otherwise you're not going to get ready for the exam. And okay, what else? Okay.
I have a question about the outline.
Okay.
Are we supposed to attach images to like our outline? Because I heard some classmates who said they were like copying and pasting some images.
You can copy and paste images if you think it will help you. This outline isn't to please me. This outline is to be something that you can review quickly before an exam and uh, make use of. I don't like the way this is angled. Okay, so I don't need images.
Okay, thank
Do
you.
you need images? Do you want them? Uh, for some people, it really makes or breaks things. Okay, so that's up to you. That's up to you. Uh, I'm going to look at your first couple that you send me. Okay, and I'm not going to ooh and ah over images because I know you didn't make them. Cut and paste is pretty easy. But I will tell you if I don't think you have enough information recorded, or you got way too much. Most people actually have way too much. They're going to end up rereading the book again. That's why you did it in the first place. Okay. Okay. What else? Okay. Let's see if I can get us back to shared screen the easy way. Can you see my cursor?
Yeah.
Yes.
Oh,
Yes, sir.
good, good. That's the easy way. Now, some of you are still latched onto that term professor. A couple of you are using the term sir. My name is Charlie, please. Okay, I'll call you by whatever you like as well. But I don't even like Charlie. I don't know where I got that. Uh, but that's what sticks these days. Okay, if you don't have any further questions, then we'll do our last portion for today, Bones Instructors Part 2. And I made myself a printout of the book's uh, pages or figures so that I can follow along a little bit more easily. You may want to do that. Here we go. Okay, these are some images that people like to cut and paste. I'm not particularly fond of color. I like to look at color, but I don't like to be held accountable when I name them. I can't see or name colors very well. When I was 18 years old, I did the very first thing every 18-year-old kid did. Every 18-year-old boy was expected to do in Southern California. What do you think the first thing was?
Did you get a tattoo?
No, I didn't get a tattoo. That didn't come till later.
Did you buy cigarettes?
No, didn't buy cigarettes.
Lottery ticket?
Lottery ticket.
But there was no lottery when I was 18. Come on.
A job?
I was looking for a job. Yeah, I wanted the job. But I wanted the job at Disneyland. Okay. Which I got. But only because the first thing I did when I was 18 years old, my birthday, I drove to the post office to register for the draft. You had to register for the draft on your 18th birthday. And then I could take the draft card over to Disneyland personnel, and they would consider me for a job, which unfortunately they gave me one of the nastiest jobs that there was, working in food service. I wouldn't eat at Disneyland if you paid me. You could not. I just saw so much of what went on at that place. The big bad wolf and the three little pigs and the guys in the costumes out on Main Street, and they're running around and chasing girls and whatever. They really are doing that. They really are trying to pinch and feel, and they get in the back break area, and nobody will sit with them. None of the other employees will sit with them because they are the lowlights of lowlights. Okay. Oh, the experiences we have, huh? I'll tell you more about Disneyland a little bit later. True stories, I don't make up anything. Okay, here we're looking at the skull, and it's color coded. So when I give you the name of a color to look at, and it turns out that I'm wrong, I got the wrong color, you need to just butt in and correct me. Okay, so this is the frontal bone. Is this blue?
Yes.
Okay, good. And you can see where the frontal bone here is in front of the coronal suture. Goes up, it meets the zygomatic bone, goes over the eye, goes into the eye. Looking at it from an open skull at the top, here's the frontal bone going around. Okay, and it's got inserted right in it this bone called the ethmoid, which we'll see again later today. Okay, this is just to show you the placement right above the nasal cavity. Gases come in, they enter through small holes, they reach the olfactory bulb, and we can smell using this bone. Then we have a bone going across. We have a larger version of it in a moment, so I'll just be brief here. This is the sphenoid bone going completely across the base of the skull and coming out and ending at the side here. Is this yellow?
Yes.
Yes.
Okay, good. I don't have trouble with those too much. This is the temporal bone here, here, and here it is over here. The squamous portion of the temporal bone, which we did the other day, and the petrous portion down here. Is that brown?
It's red, I think.
It says that that's the zygomatic bone. The brown bones, I guess, are zygomatic, and the temporal is supposed to be red, but we don't have any red on our skull.
Okay.
It looks more like
It looks
maroon.
brown in the picture, but then on the key it looks
Yeah.
red.
Looks like
Okay,
a rust
here,
color.
this temporal, I can even see it. This temporal does not match that color, does it?
No.
No. Okay, but this is the temporal bone.
Okay.
We're not going to have trouble with that portion of it. The parietal bone up here, I imagine, is green. That's not hard. Okay, we have one on each side. We can't see it on this one because we took the lid off. The occipital bone is down at the base here, and then it comes up behind and meets here where the two lambdoidal sutures come together. This is the occipital bone, and it has the foramen magnum in it. The zygomatic bone, or cheekbone, located here. Those are considered to be the cranial bones. You don't have to know them as a group, but you do have to know them individually. You're also going to have to know all the names of these holes or fissures in some cases, but we'll get to that in a moment. Okay, this bone is the sphenoid, and we get this one out of the way because it gives people fits sometimes. I think it's a beautiful bone. Let me show you again where this one is. This is right here. Okay, and it comes out on either end on the side of the skull behind the zygomatic bone. When we look at the sphenoid bone from the top, it's divided into two parts immediately, the lesser wing and the greater wing. Here's the lesser wing. From here, follow. It looks sort of like a manta ray coming at you. I don't know if you know what a manta ray looks like. In Hawaii, you go out on a boat and they got a big window underneath it. You're supposed to see the manta rays, and all you do is get a ticket for a re-ride because there are never any manta rays. Okay, this is the lesser wing. The greater wing is all of the rest of it out here. And you can see the name for that right here. The greater wing tends to look like a large butterfly. The bone itself has holes. A hole through a single bone is called a foramen. We said that yesterday. What goes through these holes are blood vessels, lymph vessels, and nervous tissue. In some cases, nothing goes through them, but we'll get to that in a moment. These, yes. Here, this little small one is the foramen, spinosum. And the larger oval one is the foramen ovale. To me, this looks like a footstep with somebody with a heel, narrow heel, and here's the pad of the foot. And then it's kicking a ball, this area here. This is the foramen rotundum. There is a hole that goes through, but it goes forward. We can't see it. It goes to the back of the eye. These holes, the foramen rotundum, ovale, and spinosum, have independent functions. They don't work together. We just learn them together. Spinosum, ovale, rotundum. In the center, or the bridge area here, you have a depression that looks like a saddle. It's the area where the pituitary gland sits so that it doesn't get rocked too much. Your pituitary gland secretes at least 8 hormones all throughout your life for your growth, development, and further functioning. It's very important. And if you were to take the entire secretion of a pituitary gland and collect it in your lifetime, it would be roughly 4 drops of hormone, 4 drops of fluid. That's it. That's how potent it is. Okay. Anyway, this is the sella turcica. The sella turcica has 2 exits from it. One here, there's a hole, it goes this way to the eye, and the optic nerve goes through it. One on the other side. This is the pair of optic canals. We'll see them from the eyeball side in just a moment. Okay, check your mute, please.
May
This
I
is
ask
the-
a question?
Yes,
So I'm referring to the screen that you're sharing right now, and then I'm looking also in the textbook, just kind of wondering, like, do we need to be able to decipher these images, like from, is there specific ones we should study because they look slightly different? I mean, they're the same. I don't know how to explain my question, but
I know what you're
there's like,
saying.
okay,
Okay, if I were identifying parts of your face, like your eye color or whatever, the next person is going to be different, but I still need to know it. Even though they're different, I need to know it. Now, if you think that that's being, I'm not understanding what you're saying, make notes if you would. And the start of tomorrow, I'll take a look at it with you. Okay?
okay.
Now, right now, I'm looking at the sphenoid bone, and I'm looking at my study guide that is available to you on our site. And that sphenoid bone is figure 7-9. It should be 7-9 in any of the Merriam books. Okay. I know you can't get to your screen right now, and I wish I'd have been smart enough to tell you that, but I wasn't. Okay, so that's figure 7.9. I'm looking at that on 7.6, we had the optic foramina, the rotundum, ovale, and spinosum on 7.9, the sella turcica on 7.9, and then we've got one more, the pterygoid process on figure 7.10. Here's sphenoid bone again. This one, although it's smaller, and of course I can increase it a bit, this one's just what we just saw. Okay. Here too. Spinosum, ovale, little bit of rotundum. When I say a little bit of rotundum, It's not good enough for me to test you on. The test questions that I give you will be clear. Okay. Here you got spinosum, oval, and you do have the rotundum showing right here. I skipped over something that's not a part of the sphenoid bone, but at the back there are two tube-like structures, one here and one here. They're called the foramen lacerum. You'll see them again in just a second. Maybe if I go upwards, here's the foramen lacerum. Here's the foramen lacerum on either side. They look like they would be important foramina, but first off, they're misnamed. They're misnamed and we have to live with it. Nobody was up to changing it. The international standard isn't going to hold. Why are they misnamed? Because they're not foramina. Foramina is the plural of foramen. And if this was a foramen, it would be a hole, not a busted piece like this, the half of the hole, going through a single bone. And yet it's attached to the bone in front of it, which is the occipital, which you don't see, and the sphenoid. It doesn't meet any part of the definition. But when we look at an x-ray, we see these guys. If you've ever had a head x-ray, you put your chin down, or in some cases your chin up, because they want the x-ray to capture these. These are your markers. These are filled in your lifetime with cartilage. No blood, no nerves, no lymph goes through it. It's just there. It has no real function that the rest of the bone has, okay? But we just got through saying it doesn't have to have a function. But we use it in x-rays as a marker, and we can find everything from there. So we've made a use for it, but nature didn't. When we take this bone, looking at it from the top over here on the left, and then rotate it away from us towards the top, we're going to get a posterior view. And here's our greater wing. Here's our greater wing over here. And here are two pedestal-like legs. They're called the pterygoid process, singularly, or pterygoid processes. The P is silent. Okay, here's an expanded view of the inside of the skull. Here's our frontal bone again. Here's the ethmoid bone. The ethmoid bone. What color is that?
It looks like dark green. Or like-
Turquoise.
Looks like aqua.
Yeah.
Aqua.
I
I
say
don't
aqua.
even know what that is. When I was a kid, I had a box of crayons with 8 or 10 colors in it. If it doesn't match those, I'm lost. When I was at the draft board getting my physical, they asked me to tell them the number on a camouflage to block. It was all camouflage with different colors. And I told them, after I went through about 15 blocks, I said, I don't see any numbers in any one of them. I don't see the numbers. Other guys were shouting out all these numbers. And I said, except for the last one. The last one was number 29. And that is the key for a person who is totally colorblind, that they'll only see the 29 at the end. I'm not totally colorblind. Their test doesn't quite work, but I am partially colorblind, that's for sure. Okay. Well, they found out that I was partially colorblind, and they bumped me to the head of the class. They like colorblind people, people who see through camouflage and are not fooled by it. Oh God, I didn't know that. Okay, here's the ethmoid bone. It has a part that sticks up. Now, you can't see it from this angle. this sticks up like a little peak. This is the Crista Galli. Then on either side, here or here, you have what's called the cribriform plate. That's all you need is another word like that. Okay, I know. Here's the cribriform plate, and it has small holes. See little holes that allow the gas to come up into the brain area. That allows what you're breathing in, the smell, to come up to the olfactory bulbs. And those holes are called cribriform foramina here. They're also known as olfactory foramina, which is my personal choice. Olfactory. We'll have plenty of days for me to repeat that for you. Either one is fine with me. That's embedded in the frontal bone. Now you're seeing it above the frontal bone, and it also extends downward. We'll have to look at it downward in the nose itself in a moment. Is this blue?
Yeah.
Okay. This is our sphenoid bone again. Nothing new here. Optic foramina, sella turcica. Here's the foramen rotundum, looking much nicer though. Here's the foramen ovale. Here's the foramen spinosum. These unmarked structures here were the foramen lacerum, which I told you a moment ago are named improperly, but we are stuck with that name. This structure here is coming in from the temporal bone. And this is the internal auditory meatus. I think I showed you this yesterday. Below it is the jugular foramen. You do not need to know the groove for the venous sinus. You do need to know the occipital bone and the foramen magnum. The parietal bone is here. Temporal back here again. This hump that you see right here is part of the petrous portion of the temporal bone. The squamous portion is this flat portion. In the eye, we have two structures. Hang in there. I don't see them on the sheet, so I need to add to this sheet for you. This structure here looks like a boomerang, and these are fissures. A fissure is not a hole, it's a slit. Okay, this is the superior part, this is the inferior part. This is the superior orbital fissure. This is the inferior orbital fissure. And they allow for muscles to come in that move the eye. We can't see very well, anyway, the optic foramina. There's one here. It was called optic canal on the previous picture. I'll go with that. And here's one here, but I'm sure I've got a better picture for you. Here are the nasal bones, nasal bone, the maxilla or upper jaw, goes up here in between the nasal bone and the lacrimal bone. I do have a better picture of that going up. Okay, I put in this picture for the things that I labeled. And here we have a partition in the middle of the nasal cavity. The upper part is the perpendicular plate. The perpendicular plate, up and down, is the perpendicular plate of the ethmoid bone. The ethmoid is up in here. You can't see it, but it sticks down and makes up the top half of the nasal septum. The lower half, in a different color for you, is the vomer. The vomer goes all the way back, whereas the perpendicular plate stays pretty much right where you see it here. The vomer goes back, and you'll see it in a moment from the other side. The alveolar process holds the teeth. We have an alveolar process for the maxilla, and not shown in this one, but in another picture, an alveolar process for the lower teeth. Okay, now we're looking at an underview again. The top of your mouth, the roof of your mouth, put your tongue against it just quickly. Okay, in the front. That's called the hard palate commonly, but it's also known as the palatine process of the maxilla. That maxilla bone here extends inward and makes the roof of the oral cavity. This is the palatine process. Back a little farther, it smooths out. Now, some of you can do this, and some of you can get frustrated trying. But if you put your tongue back up on the hard palate, and now run your tongue as far back on the hard palate as you can, it should feel like a slight speed bump, very slight and very smooth. If you find that, well, you're lucky, but it's not necessary. When you find that, though, that's where a special bone is, right here at the back of the palatine process. This is the palatine bone, bone of the palate. And laterally, palatine bone has palatine foramina that I'm pointing to now. Usually a pair, sometimes two pairs. Got a second hole right here. I don't see it over on the other side, but that's not unusual. If you see the palatine foramina, then you know they're in the palatine bone. And yes, I see it too. Foramina does not have two M's. So I'll go through and make corrections.
I have a question.
Yes.
So the palatine bone and the palatine process, I can't really tell, like I have it printed out too, but I can't really tell what the process is. Is it like a little bit higher than the palatine bone or?
Well, it
Like, what
depends upon how you're, we have directional terms, and they don't fit very well here. Okay.
Right.
But this, follow my arrow, is the palatine process.
Okay.
And the palatine bone is down here. And let's see if we can get it in color. No, not there, but I think it's coming up.
Okay. Thank you.
The palatine bone is the only one that has these holes. When we talk about a cleft palate in a newborn, We're talking about this portion here, not sealing properly. The vomer is an upright portion of bone right here. We saw the vomer here. It goes backwards all the way and comes out here. And it will separate the nasal cavity into two immediate halves, left, in this case, right and left. Sort of quickly reviewing, we got one more first. This is the mandibular fossa. A fossa is a depression meant for an articulation. In other words, take one hand and like you're going to catch a ball, okay, like you're going to catch a hard ball. And then take your other fist and make it into the hard ball and put the hand over the ball, okay? The part that is depressed that caught the ball is the mandibular fossa. And what is it going to get? It's going to get a part of the mandible. When you open and close your mouth, you're always using this temporal mandibular joint. When you're eating something that's chewy like taffy or too many pieces of gum and the sides of your face and your mouth hurt in the back in front of your ears, that's the mandibular fossa. There's one over here. Here's our foramen magnum from yesterday. Here's our occipital condyle. Here's the carotid foramen. The jugular foramen is showing here. It's a nice one. These are the foramen lacerum. You can see the spinosum and ovale from the underside, but you cannot see the rotundum from this side. The rotundum is taken off going towards the eye. And then here's the mandible that I was talking about, your jaw. If you take and your thumb and index finger, okay, and put it around your lower jaw, just put it around the whole thing. You are holding your mandible by the body, At the forward part of the mandible, right here, there's a small hole on each side. You probably can't feel that, but your dentist looks for it whenever they have to put any anesthetic in for the front teeth. The alveolar process above this time of the mandible holds the lower teeth. Find the angle of your jaw. I'll be getting into some pretty easy terms. That's great. Find the angle at the back on each side. Now, I don't know if you, I only saw it once, but people seem to still know about the Home Alone kid, where he slaps two sides of his face. So, slap or touch or press above the angle, the two flat parts of your mandible. Each one of them is called a ramus or arm. The plural of ramus is rami, R-A-M-I. And now the part that fits into the mandibular fossa is the mandibular condyle. So I can open up my jaw and close it a few times and I get crackling. It doesn't bother me normally. Now I'm quite aware of it. That's the mandibular fossa, condyle. Go across this indentation to this part, which does not have articulation, doesn't join, but it drops down. This is the coronoid process. I remember the coronoid process because when you open your mouth wide, the coronoid process drops towards the heart, whereas the mandibular condyle stays put. On the inside of the ramus, you have the mandibular foramen. We had the metal foramen over here, and now we have the mandibular foramen here. And that too is something the dentist will look for to numb the back of the mouth. I used to hate the dentist. A filling broke or came out, I wouldn't tell my parents until it was so painful because I didn't want to go to the dentist. I was scared of the dentist. Why? Because when I was a kid, my mother was the one who had to drive me to the dental office. We didn't have a car. And that guy, big guy, would grab me or my sister if it was her turn and hold us still and put the drill in our mouth without any Novocaine and drill and drill and drill. It was painful. And now I've got a great dentist, great dentist. It's a woman dentist. I never thought I'd do that. But I've had it with those two powerful guys who like pain. If anybody wants a recommendation, let me know. The reason I really like her so much, I go in now, I get in the dental chair, and I almost instantly fall asleep. They had to wake me up when they were doing a double root canal because they thought I was over medicated or something. I wasn't. I was just relaxed. It's absolutely a relaxing experience. No gas or anything like that to do it. She's fast. She's very, very fast. And the reason she's so fast is she's from Ukraine. And in Ukraine, they do not use Novocaine or anything like that or gas for any dental procedure except extraction. Then they'll use it. So if you want a root canal, you're going to get it, and you're not going to get any Novocaine in Ukraine. So she has to work fast to get it over with fast for them. Here she can use the anesthetic, of course. It's fun to go into her office. Everybody speaks Russian. Okay. These 3 bones on each side, so a total of 6, fit into the ear. They actually are inside of the temporal bone. These are called the ossicles, and they're the malleus, incus, and stapes. Yes, you will be asked one time to identify one of these, and you'll have to do it by malleus, incus, or stapes. I know many of you probably were taught also that this is the hammer, okay, and a stretch of the imagination here. This was the hammer, this was the anvil, and this was the stirrup. Well, this one does look like a stirrup, but you got to call it stapes. This one does look like an anvil, but it looks more like a tooth. And how many people do you think I could run into in a class our size that have never seen an anvil, don't know what an anvil is unless it's from a Wile E. Coyote cartoon? So I don't use anvil. It's incus, incus. And the malleus is the other one. Okay, always with a larger head. Malleus, incus, stapes. Please learn them in that order, M-I-S, because from the outside of the ear to the inside, that's the order that sound causes them to vibrate. Here's the eye. Now this time you can look medially in the eye. Okay, here's the nasal bone here, so you know this is medial. And this hole is the optic canal. Here, still unlabeled, I'll have to get a label on it, is the superior orbital fissure, and then the long inferior orbital fissure to let muscles come through. We'll start over here at the sphenoid bone. It took a lot of looking at that one. Here's where it comes out at the side and makes a part of the cranial case. But it's also makes up part of the orbit of the eye, this part here. You can take a thumb and index finger and put the thumb on this side, for instance, and the index finger over here, and squeeze. And you would be able to convince yourself that you're dealing with the same bone. Well, as I said, when we finish going through these with images, I'll be pulling out actual skeleton and setting it up beside me. Here's the zygomatic bone here, and it creeps inside of the orbit of the eye. So we're going to learn which are the bones of the orbit of the eye. The zygomatic bone does it. Sphenoid bone does it. The frontal bone does. It curves underneath and makes the roof of the eye. Come back to the other side. Here's the ethmoid bone again. I showed you the ethmoid bone from the top. I showed it from inside the nose. I didn't show it to you from the two sides. Two small, smooth sides. The ethmoid bone makes up part of the orbit of the eye. From yesterday, here's our lacrimal bone. Makes up part of the orbit of the eye. And here's the maxilla, which I showed you a moment ago. But now you see that it curves in and makes up part of the bottom of the eye. There's actually 7 bones that make up part of the eye. I've only shown you 6. Maxilla is 1, lacrimal 2, ethmoid 3, frontal 4, sphenoid 5, and zygomatic 6. The 7th bone is the palatine bone. And there's no way in heck I'm going to be able to show you the palatine bone way in the back there. It makes up such an insignificant part. So I want you to know these 6. I got away for many years now just by asking you guys, what color is this? I have the greatest trouble with purples. What color is that one?
That one's purple.
That is purple.
Yeah.
Okay. Well, what's happened is after people correcting me so many times, I memorize a few of them. I mean, if I ask you to memorize hundreds of terms, I should be able to memorize a couple. But I always had a different view on what color was which, and it had to match the crayon box. My mother decided that I was going to go to Catholic school. Did you ever have to go?
My entire education.
Who said that one?
Me, Randy.
Okay. Oh, before I go on with that story, I know some people have religious holidays coming up during our class. I checked and they do not coincide with a test date. So that's not going to be a problem, but you got to prepare for it because we're going to have the test on the correct dates. So you might want to try to get ahead. They're on the 19th and 20th of July. Okay. As far as Catholic school, I didn't want to go to Catholic school. My mother from England did want me to go. My father, a Baptist, really didn't give a darn about anything. So off we went to Catholic school in San Francisco, walked up the hills, didn't have a car, and I'm saying I don't want to go. And here are 2 nuns at the school, at the church actually, and you know the myth or whatever that the nuns look like penguins. These nuns look like penguins. I mean it. And I was only 5 years old. I'm scared of these 2. One of them grabbed me by the hand, had a death lock on my hand. My mother said, "You're going to go. You go in there." So I went in, and one of the things that we were told is nuns are quite strict. And it wasn't 5 minutes or 10 minutes in there that I learned the proper way to hold my hand so they could beat it with a stick. And that wasn't good. And then they showed me where that secret spot on the top of your head is, between the somatic and sensory areas. If they hit it with a pencil, you could almost knock you out. And then they would drag some poor kid into the back room, the cloakroom. We had cloakrooms in those days, and give him a whacking. I didn't know where the learning came in that first day. And when I was taken back outside, because my mother was there to pick me up, because I had to learn the route to get there, I told her, "I don't want to come back. I don't want to come back." And she said to me, "You're coming back tomorrow." And the nuns, I could just feel it. They were so happy, you know. And so the next day, my mother took me, and the nuns dragged me in with a death lock on my hand. I didn't know what was going to happen in there. And they brought me out at the end of the day, and they told my mother, "He can't come back anymore." I was so happy. He can't come back. You know why I couldn't come back is we had a project that day, and it was to do a coloring book page. It was a picture of Jesus, and I drew Jesus the wrong color. I couldn't get the colors straight. I drew Jesus brown, dark brown, and they had a fit. In those days, they would. These days, I think it'd be acceptable. Anyway, that's the only time I was glad to be colorblind. Although I don't even think I knew I was colorblind. Okay, any last questions that you have? Now, for those of you who think maybe these are too many terms, okay, use the guide, print the guide out for yourself. The number of terms are not going to get less. You're going to get exactly what the regular class gets, and you're going to score better than they do. You got to trust me on that. You're just going at twice the speed. You're going at twice the speed, so it's going to feel a little tough at first, and soon enough you get into a routine, and you do fine. Summer classes always do better than the spring and the fall classes do. Okay. If you are concerned, then you can give me an email, and I'll listen to you. Okay, then. Uh, if you have any questions that you didn't want to ask in front of everybody else, you can hang around. Otherwise, you can exit and have a good evening.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you.
Bye-bye. Them or just me? Oh, I didn't mean to do that.